All right. So far, we've went over two things. One, we went over how functions are best conceived as a blueprint for a machine that at invocation is created. So you have a definition, and every invocation creates a new real working machine. Second thing we went over is the difference between expressions and values. How values are things like numbers and strings and booleans and arrays and objects, and expressions are snippets of code that evaluate, that become an actual value. And how you can't add two expressions together. First, you have to turn those expressions into values, and then you can add them together. So with both of those concepts in mind, I want to walk through an exercise that will help us utilize everything we've learned so far. So I'm going to copy a bit of code here. Okay, we have a function called add countdown, very similar to the last one, but a little bit different. It takes a number as a parameter. If number strictly equals 0, return 0. Return number plus an invocation of add countdown. Let's run through this code. We invoke it with 3. So what happens? A new execution context is created. A new runtime instance is created. There we go. Okay, but this time number is not number. It's replaced with what? That's right, 3. Okay, now this, what does this evaluate to? This is an expression. What does it evaluate to? Does 3 equal 0? No, so what does it evaluate to? False. Exactly. Now, an if false statement will never run. So we can just delete it, forget about it. Okay, now we have a return statement. Again, a return can't run until it knows what it's returning. Okay, and this is an expression here. A equation is an expression, so we have to do this first, but we can't add 3 to a function invocation because we don't know what that function invocation returns. Right, so what happens when we do this? Well, this is an expression, so first we have to evaluate this. What does this get evaluated to? 2. And what happens because of this invocation? Another runtime instance of add countdown is created. But this time, what is number? 2. Why? Because that's what the argument is. Okay. What does this evaluate to? Why false? Because 2 doesn't equal 0. False. Okay, so we can just forget about that. We don't even need it because that if statement will never run. We have a return. We have an equation. We have a function invocation, and we have another equation. What will run first? Well, the return can't run because it doesn't know what it's returning. The equation can't run because it doesn't know what the second argument or the second part of the equation is. And the invocation can't run because it doesn't know what its argument is. So what is the first thing that it has to evaluate? Well, it's this equation here. This can run, then this can run. Okay, now when that runs, what happens? A new runtime instance of add countdown is created. But what is the argument this time? It's 1. Okay. Now, does 1 equal 0? No, so that returns to false. And if false will never run, so we can just delete it. We have a return, but that can't run because it doesn't know what it's returning. We have an equation, but that can't run because it doesn't know what it's trying to add. We have a function invocation, but it doesn't know what its argument is. And we have an equation which we can run. 1 minus 1 is 0. Okay, now this runs. Another runtime instance of add countdown is created. What is our argument this time? Well, as we see in the invocation above us, it is 0. 0 equals 0. What does this evaluate to? True, because 0 does equal 0. So we get to this line of code, return 0. Now, again, this might be where things get a little tricky for you. But remember this line. At runtime, a function invocation is replaced with whatever that function returns. So we know that this function is returning the number 0. But where is it being invoked? What line? Line 10, right here, right? So this whole thing is going to be replaced with what? The number 0, because this function returns 0. So we replace that with 0, and that function goes out of memory because we returned. Once you return, it's as if the function never existed. Okay. Now we can do this, right? Because we know what both numbers are. 1 plus 0 is what? 1. Now we can do this return because we know what we're returning. Again, where does this number 1 go? What's our rule? At runtime, a function invocation is replaced with whatever that function returns. So where is the invocation of this function? It's right here. So what is it replaced with? 1. Okay, now this function can be erased from memory since we already returned. This equation can run. This return can happen. Where does it go? At runtime, a function invocation is replaced with whatever that function returns. This function returns 3. Where is the invocation? Right here. So this gets replaced with 3. This function can zap out of memory. It's as if we never even knew it existed. This equation can run. Now finally, the final return can happen. This 6 gets returned. Now where was this function invocated? Over here. So in essence, what's going to happen is this is going to be deleted, and this is going to be replaced with 6. That's how recursion works. Okay, now the next exercise is I want you to mimic this exact setup I have here. What I have is I'm an atom, and I went to view, and if you click on view, you can say panes, and you can split right. Now I have 2 separate JavaScript files, one open in each pane, and I have my, on this side, where am I? On the left, your left, on the left side over here, I have the code that I wrote. And on the right side, I have what I imagine is in the interpreter's mind. So next exercise is I'm going to give you another recursive function. And I want you to write out what every single invocation looks like, all lined up, all listed out. And then together, we'll go through and we will walk through it together and we'll see how correct you got. All right, looking forward to it.